Just one bad data point can be enough to skew your analysis and lead you down a path of data ruin. So we'll learn how to hunt down outliers and deal with them accordingly. Welcome, friends and foes, to another Data Devotional. I'm Luciano Pesci, founder and CEO of Emperitas and Nexum. Today's devotional is focused on a very narrow but very important problem: outliers in data, dealing with leverage. What is an outlier? An outlier is a value that is abnormally high or low compared to the rest of the data in your distribution. The issue with outliers is if they are large enough, they can start to exert something called leverage. Leverage here means the same thing that it probably means in your imagination. The data is having an undue influence on the rest of the distribution. The reason this is a problem is that if you're using average values, you'll watch those jump around wildly, depending on how you're dealing with the outliers. And that's a sign of their leverage over the data. Today, we'll also be dealing with a real example from the Utah Shakespeare Festival. This is coming from their 2013 Customer Journey Survey of their patrons. The only field from that survey that I'm sharing with you today is the customer lifetime value metric as it was calculated by their ticketing system. This is a point of sale system that works online and at the box office, and that aggregates the total ticket sales by email address. The reason we're using this as an example is because it contains one of the most interesting real-world outliers that I've ever seen in a dataset. This observation was 57 standard deviations above the mean, which will mean more to you momentarily. But this is a very large value in a very large sample size. This dataset has more than 4,000 rows, each row being a survey taker who was also a customer with a customer lifetime value. Often when the issue of outliers comes up, it is about whether the data is valid or not. In this case, that was our working assumption. This value is so high and so far from the average, it must be wrong. We dug into all the potential reasons that this could be the case. All were ultimately rejected. And in the end, an open response survey question allowed us to identify who this customer was and to validate that this was in fact a real observation. If you'd like to find out more about the Shakespeare Festival, I've linked to their website here, bard.org, on the slides. Before we solve this problem with real-world data, let's detail the two methods that are used for identifying and then allowing you to deal with outliers. The first of these is the Interquartile Range method. This is a non-parametric method that uses the median. So it sorts the data. In this case, it would be the CLV field that's been provided inside of the project file and inside of the Power BI file, both of which are linked in slides coming up. But for this approach, it literally sorts that column and then identifies the value at given positions of the distribution. So this is about their position, not their value. You find the median by finding the middle position. You find the first quartile and the third quartile by their position. Then you see what the value is. This allows the IQR method to be more resistant to outliers than the next approach that we'll cover coming up. But what's important to understand, both approaches will set up boundaries. In this case with the IQR, it uses the position of the middle 50% of the data to determine the interquartile range. Then it adds and subtracts a multiple of the IQR to the first and third quartiles to set up the boundaries beyond which any values are considered an outlier. The further the values get out, the more extreme they become and the more likely they are to have leverage. This approach is nearly identical to the second method, which uses the standard deviation. Like before, it's going to sort the data, but then it's going to look at that distribution of data in a different way. This time it will use parametric methods, specifically the average and the standard deviation, measures of center and spread. What you're seeing here with this visualization is the amount of the distribution that is contained within 1, 2, and 3 standard deviations under the assumption of a normal distribution. So within 2 standard deviations, you should have roughly 95% of the data. Within 3 standard deviations, you should have roughly 99% of the data. This means that whether you choose to use 2 or 3 standard deviations, and it is a choice, that you will be setting a higher or lower bar for what constitutes an outlier. And you'll see when we dig into the software momentarily how much that can change all of the values involved. One final thought, these are related methods. Specifically, they are complementary methods, and you should look at both. Both methods use the same data and will come to similar conclusions, especially under a normal distribution. But since most of the data that you'll be dealing with is not normally distributed or not approximately normally distributed, they can differ, and what you'll see is that the IQR method will identify far more values as potential outliers than the standard deviation approach, especially if you're using the 3 standard deviations. Which of the resulting sets of values that you opt to use should be driven entirely by the business problem that you're trying to solve. Speaking of solving, let's jump in now to the software and see how to identify and to deal with potential outliers. We'll start in RStudio. This is linked to the RStudio project. Again, this is a compressed working directory with all of the necessary files. You're just going to see a project file, a script file, and a 2-column data file that has the respondent ID and the CLV value for each of the 4,000 plus respondents. We're now looking at RStudio, and you're seeing the script that I've written. The outline here will welcome you, import libraries, go through the most acronym, so the measurement, the origin, the scope, and the totality. I've detailed that about this data set for you. Then it repeats some of the EDA steps that you've seen for the Silverman survey over the last few weeks. And then it details the IQR and the standard deviation approaches, presents all the values, plots all the output, and gives you everything that you would need to decide, am I going to use the IQR approach or the standard deviation approach? The benefit of this RStudio project over the Power BI dashboard is that you can follow along with my thinking line by line with all of the comments. So this is a tutorial not just in how to apply both approaches, but my own thinking in how I apply it whenever I come across a data set where I suspect there are outliers. Compared to some of the earlier scripts that have been shared, this is fairly straightforward. If you have questions, feel free to reach out with them. If you find errors, please point those out to me. But from top to bottom, this should give you a good introduction in how to detect and then deal with outliers. As I've said before, I really appreciate doing this portion of the work in RStudio because it can be replicated and shared so easily. I will say, however, it's hard to compare the values that you're getting and the visuals that you're producing within this format. So while it's good for worked examples, while it's good for finding and hunting and proving what has been done, if you want to more clearly see the distinction between the resulting distributions as you make decisions to trim things, something you'll see within this script, that's better seen in Power BI than it is in the output produced here in RStudio. But as before, you can run from source. Everything should run. All plots will be here. You should be able to see the box plots and the density plots, but this is a very straightforward script and follow along with the logic of what I was doing as I was going through it. Let's move on now to Power BI, where you will see the exact same analysis applied in a very different way. The link on the slides will bring you to this PBIX file. It is a 5-page dashboard. Each page has an identical design. What differs is the application of the approaches that were laid out in the RStudio script. So we have customer lifetime value overall here. In this plot, you can see everything is compressed right up against the axis. And then we have these high outliers occasionally well beyond what you will see as any of the boundaries that are set by either of the approaches. Like in RStudio, I've tried to replicate a lot of the summary output. You can see here the sample size, the min, the average, the median, the maximum, and the standard deviation. This will be the same layout page by page in the dashboard. What will differ, and you'll see it in the titling, is the constraints that are placed, just like they were done in RStudio, on the same data. So now we can look at the lifetime value data when we drop zeros. I didn't mention this. As you dig into the RStudio data, you'll see that 0 values were discovered to be null values that had been recoded by the software, so they were dropped, excluded. We saw them in the initial distribution, and as they were dropped, you can see how it changes the average value. The average goes up. The minimum also went up. The median remains largely unchanged, the max stayed the same, and the standard deviation changed. You will see a similar shift in these values as we apply additional filters. Now we're looking at no zeros, and we have trimmed with the same IQR method. So we have set, and you can confirm for yourself here in the filters, a page-wide filter, the same upper bound cutoff of 2657.5. So that has been applied to this entire page, which is why the visual changes. It's why each of the cards in the dashboard change. And it's based around the same results that you can see in the RStudio file using the IQR method portion. Here we have the same analysis redone with the standard deviation approach. We can confirm, like before, using the page-wide filter, that what we're looking at is the same maximum value of 26,509.91 for our upper bound cutoff. We're starting to see a little bit more detail as we cut off the outliers through those filters. The question then becomes, which of these should we use? Should we be using this standard deviation that has an average of 1.3 thousand, or should we be using this IQR approach that has an average value of 500? These are very different values, almost by $1,000. Which do you recommend to the decision makers who have to do things like pick the price of tickets and determine advertising budgets? If you can expect that the average customer is going to show up with $1,000 additional dollars, that gives you a lot more flexibility. But is that a bad assumption? Because most customers in either approach we can see are clustered around less than $500. And for that reason, I've added a 5th page that's not in the RStudio file, which is the same filters now applied as though the outliers were any value above 500. I am not making the case that any value above 500 is an outlier. I'm saying that I'm applying the same approach to just see what the distributions look like when I cut things at 500. If I wanted to look at, say, the majority of the data, which happens to fall from about $500 and below. Now the distribution is becoming quite clear. We're seeing detail that we can't see before, and that is the issue of leverage. If we had gone with this initial value and just said, we think that the value is 1.4 thousand, that's the average that we get from all customers, that's not an incorrect statement, because as you'll see in the RStudio file, and as was pointed out in the slides, these values, these lifetime values, these high lifetime values, they are not bad data points. They're real customers. All of our analysis demonstrated that they were genuine values. So it is true that the average value of this sample is around 1.4 thousand. That is not what I, as a decision maker, or as an analyst, would recommend to decision makers as the value that they use, because we saw some issues with zero values. Those were easy to fix. That brought the average up. That brought us closer to a true value. However, we know there are a lot of outliers who have considerable leverage over the data. And when we trim those patrons out using the IQR method, the value drops down to 500. In this case, I would opt to use the IQR over the standard deviation approach, and I would present some analysis of the bulk, meaning 60%, 70%, the supermajority, however you want to label it, because so much of this data is still being affected by a few higher value customers. And if you're trying to talk about what the average person is like, if you just grabbed someone in the lobby and asked them what their value was, it's more likely to be clustered somewhere down here than it is up here. So while these are not outlier values, their presence is still distracting a little bit from the truth, which is that most of these customers have a value between $1 and $200. Again, that file is accessible using this link on this slide. Keep your own data progress going by downloading both the RStudio and the PBIX file and playing around with the cutoff points. Change the standard deviation from 3 to 2, see how that affects things within RStudio, and apply different page filters within Power BI to see how the distribution and the summary card stats change. And I'll see you at the next devotional.